Hi everyone, welcome back to our channel. Today we are going to solve problem number 8. This is nothing but write the loop equation in frequency domain. Okay, so here first you need to understand what is given in the problem. So this is the self-inductance of coil 1, this is the self-inductance of coil 2. So generally how to write down self-inductance is in S domain we can write down it as a plus J omega L ohms. Okay, so this omega L ohms is actually written from plus J XL ohms, where XL is called inductive reactance. So XL can be written as omega L, but what is given here? So the given value is plus J omega 1 ohm. So therefore, what is the inductance of this coil is L is equal to 1 Henry. Okay, so L is equal to 1 Henry is given in the problem. Similarly, when you compare this equation also, this is plus J omega 1 ohm, and given L2 value is also 1 Henry. So these Henrys are converted into ohms by multiplying them with J omega. It's nothing but J omega 1 is ultimately converted into ohms. That is the importance of frequency domain. So for an inductor, you write down it as plus J XL ohms. Okay, so in frequency domain, we will write down it as a SL ohms. Okay, where S is equal to J omega L ohms. So XL is equal to J omega L. Okay, so this XL J omega can be written as S into L ohm. This is how to write down. Okay, so now we can write down this as a next one is minus J XC ohms. Okay, so this I can write down it as minus J XC can be written as 1 by X, I mean 1 XC equal to 1 by omega C ohms. Okay, so this is how to write down. Okay, so now I want this to express in terms of J. So this is J, multiply with J and divide with J such a way that answer is not changed. Okay, so this JC I can write down it as a J square is minus 1, minus into minus is how much? Plus. So J omega can be written as 1 by SC ohms. So this is style of writing in terms of frequency domain which has S L ohms and SC ohms. Okay, so this I can write down it as S 1 ohm. L is nothing but 1 ohm. Okay, so that's how to write down, but this time we can write down also. Okay, so now let's try to write down for loop 1. In order to confuse us, currents are already given. There's no need to confuse also. Okay, the current I1 is flowing in this direction, and current I1 is also flowing in this direction. So in order to do it, let's try to apply KVL, Kirchhoff's voltage law, at loop 1. Okay, so when you are applying Kirchhoff's voltage law at loop 1, let's try to see here. So this I can write down it as voltage source is equal to by the KVL at loop 1, the input voltage is V1 and the drop is, so this is the self inductance. Okay, so if you want to write down this also, you can write down it as S is equal to J omega. Okay, so S you can write down it as S1 ohms. This you can write down it as S10 ohms. This you can write down it as S1 ohms. Okay, so which is nothing but we directly transformed in frequency domain. Okay, so applied voltage is V1 of S you may get. Okay, so V1 of S is equal to, so we want to write down the self inductance of this coil. So this I can write down it as I into R. Okay, so what is the value of I can write down it as I1 into R. What is the original self-inductance of this value? Which is S1 ohms. Okay, so self-inductance is completed. So the current which flows into this coil is nothing but entering the dot is positive. I mean the current is entering the dot. For this coil is also current is, so you can see here current is leaving. Current is there at leaving the dot. Therefore, you will get here current is entering the dot and here current is leaving the dot. You will get negative sign. Okay. So therefore the mutual inductance is negative. Okay. So how to write what it is? It is also I into R. So what is the I value which is prime? Is due to another coil? No. So I have to write down it as I to current I into R. What is the R value? Which is nothing but S10. Okay, so it's nothing but how I written is S is equal to J omega. And I already told current is entering, current is leaving, automatically you will be get a negative symbol here. Okay, so this is how to write down for loop 1. So similarly, let's try to apply Kirchhoff's voltage law at loop 2. Okay, so here also in loop 2 we are applying the voltage. Okay, so you can write down it as voltage source is equal to voltage drop. I can write down it as V2 of S is equal to, and the current is flowing into the inductor. Okay, so this is nothing but voltage source is equal to voltage drop due to O inductor I into R. What is the current in this coil? So the current in this coil, which is nothing but I2, and what is the drop created here, which is nothing but S1 ohm. This is nothing but I into R. So coming to this coil, here you are going to have, so here the current is entering the dot, and here the current is leaving the dot, therefore you get mutual inductance. Okay, but negative sign. Okay, the mutual inductance is minus, and the mutual inductance of the second coil is due to first coil. What is the amount of current? The current is I1 multiplied, what is the mutual inductance value, which is nothing but S10 ohms. Okay, so this is how to write down. So let's try to write down in the standard form. So V1 of S is equal to, I can write down it as I1 S minus I2 into 10S. Okay, so here I can write down it as V2 of S is equal to, so I2 into S minus I1 into S into 10. So these are the two equations you are going to get from the. So that's how the given question is, write the loop equations or mesh equations. So this is called loop 1, this is called loop 2. That's how to write down the loop equations or mesh equations. That too in frequency domain. Frequency domain means S domain. S is nothing but how much? J omega. Just substitute S is equal to J omega here. Okay. Therefore, you are going to convert in frequency domain. You can see here these equations are in S domain. That's how we successfully get written the equation. So hope you are able to understand. So if you are able to understand my explanation well, please give a like to the video and please share this video to your friends, those who are studying these subjects. And if you have any doubts on this subject or on this topic, let me know in the comment section, or whatever the video you want, just me know. And if you're watching my channel for the first time, subscribe to my channel with the name kvthulasi. Okay, so thank you for watching the channel patiently. We'll meet with another beautiful problem. Yours, Ram.